All right, so the first day of 8.6 is solving exponential equations. Start off with a quick warm-up here. I got 3 problems for you here. Go ahead and press pause, write them down, give each one a shot. I want you to solve this first equation. I want you to simplify this second expression. And I want you to evaluate this third expression. Go ahead and press pause and hook it up. All right, so this first one, you should got 4x squared equals 44. Means that x squared is equal to 11. I'm looking good, Smith. I think I did good. So x is plus or minus root 11. How many of you got on the plus or minus? Don't forget that. If you use a square root to solve or an even root, plus or minus. All right. Number 2, log base 4 of base 4 raised to the 9b plus 11 power. Log base 4 and base 4 are enemies. So those cancel out and you're left with 9b plus 11. That's it. It's not an equation. We can't go any further. That's what's up. All right. And then the third one is evaluate. Oops. So that means that log base 9 of 34, that is the same thing as log of 34 divided by the log of 9, which is approximately, put that bad boy in your calculator, and you should get approximately 1.605. All right, good. Hey, check this out. So we're saying that log base 9 of 34 is approximately 1.605. If we were to write this in exponent form, what would this be in exponent form? This would be 9 to the 1.605 is approximately 34. Let's see if that's true. Put that in your calculator. You get 9 to the calculator. There we go. 1.605. Boom. That's pretty close. That's pretty doggone close to 34, right? So this is our solution. Good. We're going to use all these pieces in today's lesson. Now, this lesson is the big reveal. So far, I've been telling you with all this log nonsense, don't worry about why or anything. Just right now, there's these hoops I want you to jump through. Make sure that you can do these log things. I'll show you why later. Today's the day I show you why and how logs are useful to us. But before we get to it, there's one other thing I want to show you first. The first example we're going to do is 2 to the 4x equals 32 to the x minus 1. All right, so here's what's up here. 2 to the this is equal to 32 to that. Wouldn't it be nice, though, if we had, does it make sense? 2 to the this is equal to 2 to the that. That would be great if we could make that happen, right? Is there another way to write 32 that might help us? Check this out. We could write this 2 to the 4th is equal to 32 is the same thing as 2 to the 5th power to the x minus 1. Which means that this whole mess here now is, 2 to the 4x equals 2 to the 5x minus 5. Now, does it make, if 2 to the this is equal to 2 to the that, does it make sense that this is equal to that? Yeah. So, solve this really quick. I'll race you. You get negative x equals negative 5. X is 5. You could check your answer, right? Check it. If we did this, if we go 2 to the power of, if x is 5, 2 to the power of 20. Whoa, that's a big number, right? Or 32 to the power of 5 minus 1 is 4. It's the same big number, right? That's what's up. Now, I'll show you what we actually did there in just a second. But let's go on to number 2. 4 to the power of x equals 15. Notice I put some spaces here. Just a little Little tip. Hey, back in the warm-up, we had log base 4 of base 4. What's the enemy of base 4? The enemy of base 4 is log base 4. Right? That's going to undo that and bring the x down, just like it brought down the 9b plus 11 here, right? But here's the thing. This is an equation, so whatever you do to one side, you have to do to the other side. If we log base 4 this, we have to log base 4 this. So log base 4 of 4, those cancel, you're left with x equals the log base 4 of 15. Right? So, in order to figure out what number is an approximation, rather, of x, now we do the change of base. Log base 4 of 15 is the same thing as log of 15 divided by the log of 4, which is approximately, go ahead and use your calculator, log of 15 divided by the log of 4. 1.953. So it's approximately 1.953. Hey, how could you check your answer? Plug it in up here, right? 4 to the 1.953 is approximately 15. You can take my word on that. Let's go back here. Here's what happened here. Once we had 2 to the this is equal to 2 to the that, once we were at this stage right here, in order to get the 4x down and the 5x down, what we actually did here was we log base 2 both sides. That's actually what happened. We didn't actually do it because it's kind of intuitive. 2 to the this is equal to 2 to the that. But that's what happened here. All right, let's do another one. How about number 3? 5 to the x plus 2. Then plus 3 equals 25. All right. Now, we're going to solve just like any other solving problem. The first thing you get rid of is addition and subtraction. So get rid of that 3. So this becomes 5 to the x plus 2 equals 22. Right? So now we have base 5. 5 to the this is equal to 22. How do you unbase 5? You log base 5 both sides. You log base 5 both sides. So, log base 5 of 5 cancels. You're left with x plus 2 equals the log base 5 of 22. Now, here's what's up. Let's move this 2, so we got x by itself. X equals, but I'm going to put it, instead of log base 5 of 22 minus 2, you might be tempted to call that 20. That's not quite right, is it? It's going to be negative 2 plus the log base 5 of 22. That way there's no confusing that this 2 is part of this 22. So let's put that in our calculator. This is going to be x is equal to negative 2 plus the log of 22 divided by the log of 5. Now, our calculator is capable of putting that whole darn thing in here, right? Check it. Negative 2 plus the log of 22, close parentheses, divided by the log of 5. You should get about approximately negative 0.079. X is approximately negative 0.079. You could go and plug that in here and check your answer. All right, let's do one more. Number 4. E to the 2x minus 3 plus 4 is equal to 21. Of course, the first thing you do is move the 4. So, all right, e to the 2x minus 3 equals 17. All right, how do you unbase e something? Well, here, unbase 5, we log base 5. We have to log base e. What's another name for log base e? Log base e is natural log. You can natural log both sides. So now we got 2x minus 3 equals the natural log of 17. Keep solving. We're not going to round the answer until the very end. So this is going to be 2x equals 3 plus natural log of 17. So x is equal to 3 plus the natural log of 17 divided by 2. So let's put that whole mess in our calculator. But here's the thing. Be careful with your parentheses. Remember, this is a fraction, so you got to put the entire top thing in parentheses. This is 3 plus the natural log of, now they gave you a new parentheses, right? 17. So when you close it, make sure you double close. Divided by 2, and you get approximately, x is approximately 2.917. So, if you have a base where x is in the exponent, in order to get x out of that exponent, you're going to log base whatever the base is on both sides. Word, Smith out!